Sorry to hear that. Algebraic representations of reflections. So now we can do reflections too. So let's read this real quick. It says the signs of the coordinates of the figure when reflected across the x and y axis, right? So I read the words wrong, but basically we're going to figure out how when we do a reflection, we go across, we reflect over a line of symmetry or line of reflection, not symmetry, a line of reflection, and then we change some things. So if I reflect across the x-axis, then I just take the negative of whatever the y value is. If I reflect across the y-axis, then I take the negative of x, which kind of makes sense when you think about it. So let's look at example number 2. It says that the rectangle RSTU has vertices at the following points. I'm not going to read them all. And then find the vertices of R prime, S prime, T prime, U prime after a reflection across the y-axis. So now the way that they do that is if you're reflecting about the y-axis, you negate or take the negative of x. Okay? That's it. That's it. So what they are doing algebraically is they're saying whatever the value is, just multiply it by -1. So here we have -4. What's -4 times -1? +4. See how they did that? So what's the opposite of -1? +1. -1, +1. -4, +4. So they're just negating or taking the negative of whatever they have. Now, when you start off, what's the negative of a negative? A positive. Very good. Okay. So then, lastly, you can always graph the image just to double check. So here we have the pre-image, right? Remember that? This is what we call the pre-image. And then the transformed image is called what? The image. And is that reflected across the y-axis? Yeah. Does that make sense? So let's try to do one on our own for problem number 2. It says that the triangle has the vertices of A, B, C. I'm not going to say those out loud. But then it says find the vertices of A prime, B prime, C prime as it is reflected. Uh-oh, we're going to change this up across the x-axis. So now what does that mean? Well, when we reflect it across the x-axis, the x values stay the same, but what changes? The y's. We just take the negative of the y. So A prime, the x is the same, which is -2. What's the negative of 6? -6. Do you guys see what I'm doing? I'm looking at the 6 and I'm going, what's the opposite? B prime, 0 stays the same. What's the opposite of +5? -5. Very good. C prime. The x value stays the same. What's the negative of -1? There you go. Couldn't be any easier. Does that make sense? All right. So what I'd like for you guys to do now is read the algebraic representations on rotations while I post this really quick.